Alright, so we covered quite a bit in the last 2 weeks in all the courses. So I don't know, I might have to split this up in a couple of videos, but in the meantime, I'm just going to go through various assignments that I've done, that I've got marked and sent back. So here's Econ, the first assignment. So basically we've got a principal, we've got a number of years, we've got an interest rate. It's the interest type is simple, and we're comparing that to the exact same parameters except the it's compound interest. So for simple, f equals p 1 plus in. So that's just going to be for the number of years, simple interest. This is compounded interest, so this one's greater. With the cash flow, they look identical, except the type of interest determines what's going on. Okay, so this one, we want to find the tripling time. So p equals 3p. So, well, he wants me to use something else, but whatever. He marked it. B-Joy marked it. He's a hair marker. Yeah, so that's basically what we want to find, and I found the number of years. That's like pretty damn easy. Okay, so here's the next question. Find f. I don't actually have the question. Where is that? It's probably in here somewhere. Lab. Do I have lab 1? Lab 2. This is lab 2. Shoot. I don't know that I have this actual question. I think it was 15 years, 13 years, 11 years. So basically, I split the cash flow up into 3 separate ones and found the well, what do they want to know? They want me to find the future value. Oh, okay. So what I had is in different years I had certain amounts of F's, but I had principals like this. So I found each of them as separate single. It's a single payment series. Anyway, that's not hard. That's not hard. I don't know why I'm making this video. Okay, so this one, find P. The second year 2's payment was this. Year 5's payment was this, and year 7 payment was this. So it wants us to find this. So I just went. Reverse that, found that, reverse this, found that, reverse this, found that, plug that into here, added the 3 together, got a principal, or first year value. That's assignment 1. That's not very difficult. Here was lab 2. These were the actual questions. I can describe how I did them because I don't have my assignment back yet. But, so we've got 5 annual deposits in the amount of $3,000, $2,500, $2,000, $1,500, and $1,000 in that order, into a fund that pays an interest rate of 7% compounded annually. Determine the amount in the fund immediately after the 5th deposit. So deposits mean it's coming out. So we'd have like a cash flow. Annual deposits. So in years 0, 1, 2, 3, 4, 5 of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this one's 3,000, 2,500. 2,000, 1,500, and 1,000. So what I would do is I'd say that equals, basically I'd have 2,500 and then 2000. So I'd have a linear gradient series with G equals to minus 500. And then I want to turn that into I'm going to turn that into a present value. So I'm going to use G over P I N, and that's going to give me a present value for this in the number of years. Yeah. Is that how it works? Yeah. I'd get a present value, but it's sinking. So that'll give me a P. Basically, I want to be able to take this money out. And then I'd also have another series of like 500 equal payments, and I could get that P, and then take those two P's and turn it into an F, and get the future value for the 5th year. I think that's how you go about doing that, but I don't know. I'll have to get my assignment back when I make the video next week, go over it. But anyway, find the present worth of cash receipts where I is 12% compounded annually with only 4 interest factors. 4. Okay, so this one is like an equal payment series of 100, and then the next one is like a equal payment series of 50, and then another one of 50. So I want the present worth of that, so I can just split them all up and get P by adding the 3 things together. I compound annually. Yeah. Okay. This one. Okay, so this one, basically what I'm going to do is I'm going to take, I can think of this as 20. Yeah, so the leftover is 20, so it's 6, 7, 8, 9, 10, 11, 12 goes down like this. What did they want? Percent worth of the cash flow. Oh, present worth of cash flow using the at most 3 factors at 10% interest compounded annually. So I've got this, and then I've got a geometric one too. So I can, how am I going to split this cash flow up? So I've got these ones here. I want to turn okay, yeah. So I can have equal payment for these. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be an equal payment series, but these ones had this done to them, right? So this one would be, this would be going to 0, and this one would go to 20, and this one would go to 40. So I'd have that, and that would be a linear gradient series starting at year 1. Right, but I need to add to this. How do I do that? I just need more space. I know how to do that one inside out, because that one was hard as fuck. This one, okay, so I can say that that's the same thing as, what is it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So 1, 2, 3, 4, 5, 6, 7. So 6. So what's left? I've got this shit left. How do I turn that into this? I could take 20 away from all of these. So 20, 20, 20, 20. That'd be plus 20, plus 20, plus 20, plus 20. So I can now go like this. Yeah, that works. Right? So now these ones are taken. So then it's going to be this one. And I'm going to solve for p here. And then that's going to also, I'm going to take this linear gradient series here. So what do I got at year 2? Oops. 0, 1, 2, 3, 4, 5. Just year 5. Okay. So at year 1, it's 0 because that one took away this one. So actually, this guy is in there as well. So at year 2, I've got 20, 40, 60, 80, right? Yeah. And then this one gets me a p-value here. So that's 1, 2 factors, and then the third factor is you find at most 3 interest factors. So it's that p plus that p. So I only use 2, right? Yeah, because the net balance on that is that. And I can add 20 and minus 20 to both sides, and it's the same thing. Yeah, so those are the 2 values. That's all I need. Okay, this one. Yes, right. Okay, so I basically want to turn this into this, right? So this one here, I'm going to have to go, I'm actually going to copy this. 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. Like that. So I'm going to copy that. So to get this one, I need there to be a 50 here. So I'm going to split this up. I'll call that, let's call this x. So x equals, I'm going to call this y plus z, which is this. So I'm going to say we got 50, and then I'm going to take away 50, 50, 50, wait. Okay, I need 50 here. I know. I'm going to take 50 off of all of these, right? 50 off of all of those. So I'm going to say this y is going to be 50, 100, 150, and 200. So I've got 50 left from all of these. I don't know why that turned red because I had it highlighted. So then I've got 50, and then I've got what, year 2. So I got 50, 50, 50, 50. Alright, so then what I can do is this I can get as a present value here with a factor, right? This one here I can get a present value here with a factor. So I'm going to take this portion here, and that's going to go here. And then I treat that like a future value and multiply it by P over FIN, right? This, once I get this. So to get this one, I got A. That's going to be 50 times, so I treated that as A, so that's going to be A, and I want a P value, so I get P, I, N. So it's going to be that times that, and that'll give me that, but I have to subtract 50 from it, and that'll give me the present value here, and then that present value plus this present value, and I'll call that P1, P1 plus P2 equals P prime. So that P prime I'm going to then turn into an equal payment series. So then I've got P prime is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I'm going to turn that into an equal payment series of this, right? So that'll give me an equal payment series. Once I took those two P primes, added them together, and then did an equal payment series. Okay, so that'll give me some value. Let's call that Z. And I just need to make it look like this. 2, 3, 4, 5, right? Like the question wanted, I need it in A's, but this starts at year 0, so that's kind of weird, right? So I'm going to say that this is A in the 0th year plus 1, 2, 3, 4, 5, right? Sorry, this is like super quick and dirty. 1, 2, 3, 4, 5, but these are all A's, right? So then what I'm going to do is I'm going to say that this, I'm going to turn that into an equal payment series by multiplying it by A. I'm going to pretend it's a present value, right? So this is going to say A is the present value times P. I want an A, right? I, N. That's a number I can get. I'll call that B, and then so that'll give me a one with, it's called 2, 3, 4, 5. This will be B. Okay, so that A became this B, and then B plus A, because these are all a value A, right? So B plus A, it has to equal Z. Alright, so when you add those two up, it's got to equal this one that I calculated, and this is a number. But I don't have this number, and I don't have that number either. But I do know what B is. B is equal to A times A over P I N, right? So that's going to be that plus A equals Z, which is a number I have. So then I can factor out the A. This is a number plus 1. So A equals Z divided by this shit. And that's how you get A. And then you can go ahead and give the value for A. So that's basically how you do that. Anyway, it took a lot longer than it should have, but I still think it's worth to do a couple of videos on economics. I got to do some more questions because I do find it confusing, and Sastry actually gave me some questions to do. So I guess I can also do let's do deformable bodies also in this. So here's my tutorial 1. So find stress and normal stress and shear stress, I think that T is, for D, E, and F, right? So here's my diagram. I'm going to draw a free body diagram here. And then, so what I'm going to do is I'm going to look at B, and I'm going to find the moments at B, so I can get CY, right? And then I've got CY now, and then I can do the sum of the forces in the Y direction. And I think I had the weight of the beam. Did I? 800 minus 800, 9.81. I must have. Because what I'm trying to do is get force of AB. Oh, right, yeah, because it's the sine of some angle. I don't know. Yeah, I must have, yeah, it's 4 meters here by 3 meters. And then, so I got FAB, so that's the magnitude of that. And then some of the forces in the x direction, I got CX. So if I do a section at F, I've got everything I need here. VF is going to be the sum of the forces in the y direction. And I had the weight of CF, right, because I had the distance of F, and then it's in the center of that. And so I've got the normal stress there, and the strain. That's the section there. Section at E. Oh, also, yeah, the stress at D is 0 because there's no forces acting on it. So that's something I didn't put. And then the section at E. E, I'm going to do the same thing, but I've got the weight from E to D, which is there, and the weight of the engine down here. So I can find VE, and then VE over A, and I guess it must have been 10 centimeters squared. It's a square beam. So anyway, that's that one. And 2. So I've drawn a free body diagram here. I wish I had the question up. I wonder. Did I do this? There we go. Yeah. So I have the question in there for that. So that was this. So I just drew free body diagrams of the member and did the force action-reaction pairs. And I did the moments about A because that had the most forces on it, and I got FCB, and then FCB is that, and then I can do a section of this and find the tension in the normal stress in the cable, because this cable is from C to B. Yeah, I wanted that. So, and then the cross section of AB and AC. I don't think I even needed the cross section to do that. Yeah, so they like to give you lots of extra stuff in the way, right? This one here, we want the allowable diameter if maximum allowable diameter if the bolt has a shear stress of 90 megapascals. So there's a free body diagram of the bolt. I said that it was 80. The only thing to resist that is going to be those 240s in that direction. I did section 1-1. Section 2-2. Looks like I've got a shear stress of 40 kilonewtons. I basically wanted to see what the biggest shear stress would have been then. Alright, and then so I've got the shear stress that way. I must have the diameter. No, I'm trying to solve for the diameter. And it said the 90 megapascals, so that's 90 megapascals, and I can solve for the diameter this way and get that 25 millimeters. Okay, and then 15 millimeter diameter steel rod subjected to external loads at this point. Just go ahead and cut it. Look at your cross sections. There's a maximum normal stress in the rod, so just do a section at each part and see which one the biggest one is. So that'd be the maximum right there, because that had the most, the highest normal force. Okay, 24 minutes. I can finish. This one could have taken forever. So I did the moment at C. There'd be nothing going on here except for AX, right? But there's only one unknown there. So I can say that AX is this, and then I can assume that CX is the same thing, because it's the only one operating in the opposite direction. And then AY has got to be equal to P, which is 5 kilonewtons. So what did it want? Determine the average normal shear stresses on the bar at point D. So we cut it at point D, knowing that we know this, and then we can find V and the stress. Done. And I also wanted the rope. Oh, and the rope at point E, yeah. So I have CX and E. There we go. Done. Okay, this was the one where, oh yeah, I remember doing this and having a hard time with it, but it's not too bad, I don't think. Unless, was that the one I got lost a point on? No, that wasn't the one I lost a point on. Oh, I had the wrong units on 5. And I lost a point. That sucks. Anyway, yeah, so this one here, there's a force P, so if P's pulling, like let's say this, I got the board, P's pulling, it's pulling on 2 things, right? Those 2 bolts are going to pull this way. Yeah, there's a cross section of it. So we got P. Oh, and this is a plate. So on the plate, you've got the bolt. It's pulling on the plate, right? So you pull this way, and the plates. There's 2 plates on it with 2 bolts. So it pulls on the 2 bolts, which is P over 2, right? Because it's divided between the 2 bolts. So P's pulling on 2 bolts, and then those 2 bolts are pulling on 4 holes in 2 different plates, right? So I got P over 4, P over 4, P over 2, and then, yeah, that was my quick drawing. P over 4 equals V. And what did I get? I must have had the area. Oh, okay. Oh, I wanted the A36 diameter steel bolts. Shear stress. Okay, so yeah, I want to see like there's shear stress on the bolt, and then there's gonna be normal stress on the plates. So I'm gonna go ahead and look at these. That's the diameter. So I'm looking at the bolt here. So that's the shear stress there. So P over 4 equals V. Not or right. So 9 KSI equals V over A. So V would be the max because I was given the maximum shear strength, or yeah, shear strength for the bolt. And then this one here, I gotta look. P over 2, 18 KSI. N over this, N is that. 18 kips is greater than 1.8 over 2. 18 KSI. 9 KSI. 9 V. So I got P and 1.8 kips. And then that would be as big as P can be. But then I want to see like if P over 2 is less than N. So it is. So that one, these bolts are going to break before the other ones. So that would be the maximum load that it can carry. But for example, if that was greater than the other one, I'd have to go and start with the plates first, right? And look at that and then see what that P ought to be. Anyway, so you solve for one and then see what you get and compare it to the other one. And if this one's going to break first, then you just know that this one's going to be fine. All right, so that's it for those two, I guess. I mean, I'll have to go over lab 2. These were the graphs. We got safety factors. So the max stress is going to be the yield strength over the safety factor. All right. OY over that for ductile materials. Let's see, we got a helicopter. What we got? Yeah, that would be calculating yield strength. Axial deformation. So the change in length is going to be normal times the length over AE. That one's not too bad. But if you've got, there's like an integral form. Yeah, this is if the force is being applied over, it's like a gradient, right? So you need to find a way that N gets to be a function of L. So you're basically setting up a calculus problem. It's not too bad. So we were saying that N equals W, right, because of the only 2 forces acting in those directions. W equals V times the density, volume times density, and then the density is that times length times density, and then we had the area and we had the density, so we can get that W equals 8.6 L. So 8.6 over AE and then LDL, so it's L squared. So that's how you get this. You have to set it up in terms of L. So anyway, that's it for now because I'm going to run out of space.